This video is an understanding of binary numbers and bitwise operations on vectors and, or, and the XOR. But before we start looking at these bitwise operations, let's get a quick understanding of the binary numbers. So we've got two vectors, both vectors hold integer values. To understand binary numbers, each bit in the binary number system represents 2 raised to the power of its position. The decimal value is the sum of the powers where the bit is set to 1. Now that was very theoretical. Let's have a look at an example to understand how it practically works. Now let's take a look at this binary number. It can be broken down as follows. Now the bit positions of power of 2. So the first one from the rightmost would be 2 to the power of 0. So it's always 2 to the power of its position. So that would hold position 0, that would hold 1, and all the way to 7. So although we got 8 numbers, but because we start with position 0, it ends at 7. So 2 to the power of 1 is 2, 2 to the power of 2 is 4, and so on. And then what we do is, the decimal value is the sum of powers where the bit is set to 1. So whatever's set to 1, we take that value, these values, add them up, and we'll get a decimal number. So this binary number is equal to 2 to the power of 3 and 2 to the power of plus 2 to the power of 2, which is 8 plus 4, 12 in decimal. Now, another way to look at it is we can get these values by going 2 to the power of its position, 2 to the power of 1, and so on, and we get these values. And then whatever is got the value 1, then we look at it, we'll grab the corresponding value and add it up. So pretty much the first 4 values from the left is equal to 0. So we're basically multiplying these values by 0, which will give us nothing. But then we'll add up 8 and 4, which is 1 times 8 and 1 times 4. And then the last 2 bits, these two are also zeros, so no values, but they would be multiplied by 2 and 1. So in the end, we end up with those that are multiplied by 1, which is 8 plus 4, giving us 12. So feel free to choose the approach that you feel more comfortable with. Now let's look at the bitwise operation. Now to understand the output, we're going to look at this comment, but what we're looking at is the result is a new binary number where each bit is set to 1 if both corresponding bits are 1 in the input numbers. Otherwise, it is 0. And then each resultant value is stored in the new vector. So when we say vector 1 plus, not plus, sorry, and, that's going to be the representation of the bitwise and. So this really, what it will do is it will give us a new vector, giving us the result of this bitwise operation. But let's print out the result. So I'm just going to scroll all the way down to the method that we've written in a previous video called display vector. It takes up the operation name and the vector, and it prints out the details. So let's print it out. Display vector. And it's expecting 2 arguments. So the first one would be an explanation. So bitwise and. So let's see what we get when we print it out. So it's given us these numbers, and I'll explain what they mean. But I just want to print this in a bit more straightforward way. So I would like to print out a new line at the end. But in the middle, I want only the value, and then space here. So look at what we get. Okay, so that's all I want. But let's explain how we got in these numbers. So this is when we come to this comment about add. But before that, I would like to get the vectors, the original vectors. So what we then do, the resulting is a new binary number where each bit is set to 1 if both corresponding bits are 1 in the input numbers. Otherwise, it is 0. Each resultant value is stored in a new vector. So when we say 1 and 8, that's going to be a new value that's going to be stored in the new vector. That's going to be printed out. So 1 and 8, the binary representation of 1 is everything is set to 0 except the first value, because what we want is only that is multiplied by 1. So we've only got that bit turned on, and everything else is 0, 0, 0. Whereas 8 is this number here. So that's going to be, what was it? It was 1, 2, 4, and 8. Okay, so what we can do is we can also get this, this one is useful. So that's also a useful comment to add here. It will help us remember how this works. Like that. Okay, so that's how we've got an 8. So now what we do is, this is really important when we're doing AND. If both numbers are 1, then we get 1, otherwise 0. So nothing is in common. So that's 1 and 0, so that's 0, and that's also 0 and 1. So we get actually everything is with AND, both same level or same position has to be 1 to give us that number. So that's how we get that value 0 for 1 and 8. And then 2 and 7 in the binary system, that's what they look like, 2 and 7. So that would be, if we look here, that would be 4 plus 2 plus 1, which is 7. And the number 2 is only this one, which would be this value here. So what we get is 0, because 0 and 1 is 0. 1 and 1 is 1. 0 and 1 is 0. So that's how we get 2. So that gives us an explanation of the second value. 3 and 6. So 1 and 0 is 0. 1 and 1 is 1. Everything else is 0. So that's how we get 2. So that explains this output. 4 and 5. So 0 and 0 and 0, 0. 1 and 1 is 1, which is 4 in the decimal system. So that gives us the output 4. And then 5 and 4 is pretty much the same. That gives us 4. 6 and 3. So the only two values that are set to 1 is this one. So that gives us 2. 7 and 2 is also 2. 8 and 1 is nothing in common. So everything is zeros. So that gives us this resulting vector. And so that's what we mean by each resulting value is stored in a new vector. I think I'll break this video down and I'll spend the next video on OR and XOR just to make this slightly shorter. Thank you, and I'll see you in the next one.